next session comes from Andrija, who is from ShapeBlue, upgrading from Rovius CloudPlatform to Apache CloudStack. Good luck, Andrija.
Thanks, Svet. All right, good. Thanks, everybody, for attending. So today we are going to show basically how upgrading from Accelerite or Rovius CloudPlatform to Apache CloudStack works. And I'm going to actually show you also anonymized, obviously, customer project, which is kind of a production stuff. So a couple of words about me. There is an expression in English language that, to have one's teeth into something, which you can see on the picture. I used to be able to do that. For last couple of years involved in IT, also involved with CloudStack since the basically first Apache version, 4.0 incubating, PMC member, and also father to two princesses and wannabe drummer, but more on that later. Right, before we continue, as silly as it sounds, just to cover two abbreviations which we're going to use throughout the document. So ACP stands for Accelerite Cloud Platform, or in short for Cloud Platform. So wherever you see ACP in the slides, that means Cloud Platform. And wherever you see ACS, obviously it's Apache CloudStack, just to make those differences. Right, so basically what we're going to see today, I'm going to show you a high-level overview of the whole migration process. Also some detailed steps, some gotchas what to work for, where you can get bitten, a bit of what and how, and at the end I'm going to walk you through a complete upgrade project of a sample customer. That's, let's say, the last part of the presentation. Now, why not step-by-step guide? As nice as it would be to have these kind of books available, unfortunately, this is really something that doesn't really exist. So, getting serious, why step-by-step guide is not possible? Well, each customer environment is different. We have different, let's call them source cloud platform versions. We have different target CloudStack versions. Database data is different. Schemas are different. Different level of patches on cloud platform. Also, some customizations might be done by the customer. All that can influence actually the whole migration project. So what we don't cover today during the presentation are some special, let's say, cases. If you have a cloud portal business manager, which is an interesting thing to do, or was interesting thing to do with cloud platform. Some customers wanted to migrate to the LDAP, which needs a completely different set of scripts to migrate everything properly. So it's not really something that we can cover easily. The important thing is that this requires judgment calls for most of the time. So for that reason, it's really not possible to present a regular step-by-step as, well, all of us would probably like whenever we have something to learn. Now, couple of challenges. I'm going to walk you through these when we cover these in details later on, but we need to, in the first place, ensure a successful database upgrade, which is always the major pain in the neck. And once we do that, we want to ensure that we fix the database, both schema and data, to be as close to the clean installation of the same CloudStack version as possible to avoid further issues down the road. Needless to say, proper testing is needed. We are usually doing customer engagements with cloud platforms, so it's on a customer side to have a proper test environment with a proper cloud platform version and to do the functional testing after the upgrade so that you can actually see that nothing is broken. And also, we need to somehow handle the responsibility. So this kind of testing is also what we want to call user acceptance testing, so that the customer is actually happy with what we have delivered, which gives you possibility to have a proper night's sleep, or at least the cloud operator itself. Now, required technical tools on this slide for the whole project is mostly we would like to have a virtual machine. I'm going to go into details about this with the CloudStack management server install, where we will do so-called sandboxed DB upgrades. Again, more details to follow. We are going to need two special tools, or you can maybe find some alternatives. What I used was the dbForge data compare and schema compare, where you are able to connect it to two different databases, vanilla one, for example, clean installation, and the upgraded one. and then you can actually compare apples to apples and oranges to oranges to see what's wrong. A proper test environment again on the customer side, and optionally, if you are really, let's say, advanced enough, you can spin a new test environment on CloudPlatform, upgrade, and then eventually run Marvin and smoke tests to see if the results are in line with the same results that you would do on a clean, whatever target CloudStack version. Anybody aware of the 7-layer OSI model, networking model? You know, application, networking, presentation, and so on. Well, yeah, this is just a conceptual model, by the way, something that never worked in practice. In practice, we always have a layer 8, which is the layer on top of the layer 7. So, yeah, there is an interesting quote by this guy. But jokes aside, yeah, a bit of insanity, I guess, is needed, and everything else to be able to go and make a lot of judgment calls, which is what I'm trying to emphasize on. But getting serious, we need to have a proper understanding of the CloudStack upgrades, the low levels, basically how database schemas are upgraded, how SQL files are run during the upgrade, and so on and so forth. MySQL server knowledge, as well as SQL knowledge as a language to be able to change certain queries, and when we later fix things. A bit of stimulants, obviously, is as well. The allowed ones, obviously, is something you might need from time to time. By the way, this is the guy from the Back to Future in 1985. So, if you are ready, let's go. A very brief history of CloudPlatform and CloudStack. Basically, CloudStack was launched in 2010 by the VMOps, which was later rebranded to Cloud.com. It was acquired by Citrix in 2011. Then they developed it and used it for a year, donated it to Apache Software Foundation in 2012. But they have maintained their own commercial fork, which was called CloudPlatform, or at that time, Citrix Cloud Platform. Then after a couple of years, they decided to, well, not to really ditch it, but sell it to another company, which is Accelerite, but completely independent of this commercial fork. CloudStack still continues to develop from 2012 until now, 10 years, right? In a very active open source community, and is actually a de facto, I'm pretty sure I can say de facto IaaS platform these days, or at least one of the top ones. A couple of notes on the versions. CloudStack version 4.17 was released in June 2022. There were a couple of minor bug fix releases in the meantime, while, for example, Accelerite Cloud Platform is for 11.07, at least what I'm aware of, and it's roughly based on 4.10. That's the brief history of time. And now let's just cover a couple of differences. These, you can argue, are basically or essentially this is the same product, but when it comes to the upgrades and moving from one product to another, there are some serious challenges. Again, there is a database version mismatch between the same versions because, for example, CloudPlatform 4.11 is based on 4.10, CloudStack 4.10, or CloudPlatform 4.7, even, I'm not going to say worse, but even more complicated, is based on CloudStack 4.6 with some tables, indexes, and keys, improvements backported from 4.8, 4.9, and 4.10. So in that sense, you can call it a bit of, no pun intended, Frankenstein version, which is really hard to move away from. Then again, we have a feature set mismatch. For example, CloudPlatform developed for their customers some special features which unfortunately were not committed to the upstream version of CloudStack. Also some different implementations of the same thing. For example, password encoding, the number of passes in the password encoding using the given basically hashing algorithm is different because in CloudStack it was implemented a bit later than in CloudPlatform and with more passes. So when you upgrade, none of your users actually can log in, which is not an interesting thing to have. Obviously, there are fixes for this. Now, very quick on the tools that we're going to use. These are, well, have proven to be essential ones and the ones where you will spend a lot of time. We have the schema compare by the dbForge. Schema compare, obviously the idea is to compare table structures, so field lengths, indexes, keys, and these kind of things. What you want to do is you want to take a clean CloudStack installation as the source, and then you want to take the upgraded CloudPlatform to CloudStack database, both of them being at the same version eventually, for example, for 13.1. And the source, which is the clean schema, is assumed to have the correct, the source data or the source database is assumed to have a correct schema or structure of tables, indexes, and everything else, because at the end of the day, CloudStack code expects certain database structure and data as well. This tool will compare the source and the destination tables, obviously respective tables, and it will generate a set of SQL scripts which will allow you to basically upgrade or modify your CloudPlatform upgraded database to be in sync with a clean CloudStack database, or the same table, actually all the same tables of the clean installation. This still requires manual checks. It's not just click, generate, and there you go. You need to go through almost every single query generated. Very short demo on the dbForge schema compare. So when you want to compare two things, let me just find my mouse. You will hit the new schema comparison button. Effectively, it will be the same dialog as I see over here. So you'll be setting the source. My apologies if this is maybe not visible, the most visible one, but you will be setting the source database. This is a vanilla for 13, for example, and the cloud database is the one that you want to analyze. On the right side, you have the target, which is the cloud platform, which was upgraded already to whatever cloud platform. You will click next, and hit compare, and eventually we will see something like this. We have here a section which says only in source. What does it mean? We have 6 tables which are only in the source, which means they're missing in the destination database. Those are the single table and couple of procedures. So effectively, when we generate the scripts, they will allow us to create those missing things. Now we have also different ones, different because there are some differences you can see in the red. And you can go through all of these, and also if you scroll down, you will see a couple of tables or whatever resources that exist in the target one, which might be now kind of considered junk, or maybe something created by the customer that are not needed by a CloudStack. When you hit the synchronize button, you can either do a live synchronization, which is never a good thing to do, or you can open the SQL in the internal editor, and effectively it will give you tons and tons and tons and tons of SQL things to go through. Now, this is where what I was referring to. For many of these, you need to actually use your judgment and see whether all of these are actually safe to do. I'll have a slide later on to touch on the safety of these changes. Now, moving away from the dbForge schema compare, now we are with a data compare. So the idea here is to compare basically data in certain, let's call them system or static tables. So we are not going to compare data, for example, in VM templates, VM instances, logs, those kind of tables that get a lot of data from a day to day. The idea is to check those system tables like configuration table, which is global settings, or roles and role permissions, which are known by experience to be completely missing or empty in CloudPlatform, then hypervisor capabilities, and so on. Again, we have a source, the clean CloudStack as a source. We have the upgraded CloudPlatform as a destination. We'll be comparing the things left and right, and I'm going to show you basically how this is done. I'll cover in a bit more details why data changes are important later. I will give you an example how things can break if you don't do the necessary changes. So just a quick demo on this one. What you see here, it could be better if it was zooming a bit, but there you go. You see here again, I have set the source and the destination source with a clean CloudStack. All right, clean CloudStack 4.13. This was a project with 4.13, and then the CloudPlatform upgraded. You will hit next, and compare. Now, hopefully, if it doesn't crash, I will be able to show you a couple things. So let's take, this is the difference. We have only 6 different tables that we've chosen to compare. Again, I didn't choose all, whatever, 200 tables. We only choose certain static tables, system tables if you want. So just to show you an example of the hypervisor capabilities, if I double click on this one, I would be able to here choose which columns of this one I'm going to compare. And the default, all right, it seems stuck for a second. All right, it opened actually on another screen. Sorry, just to give me a second. It opened on the other screen. So here, by default, all the fields are marked for comparison, and by default, the comparison key is set to the ID. Now, this is something you need to touch on a table-by-table basis because we are comparing our hypervisor capabilities. So VMware, for example, which version? For example, 6.5. You don't want to compare rows with ID number 1 and number 2, or number 1 in another table, because VMware 6.5 might be in a source database in a position 1. In a destination database, it might be in a position 7. So the correct thing to do is to actually set that the comparison key is not the ID, but it's a combination of hypervisor type and hypervisor version. Furthermore, we want to completely exclude ID and UUID, which is always unique in every setup. We want to exclude that from the comparison whatsoever. And I'm not applying anything because it was already there. And then you will get basically a set of differences which are, it's a bad contrast, but you can see over here, this is the source, this is the destination table. So for example, with KVM, the maximum number of data volumes is marked as 32 in clean CloudStack installation, while in upgraded CloudPlatform it's 28. Now I can tell you technically that 28 is probably the correct number because of the number of PCI devices, yada, 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 but we need to make sure that it's in sync because of any further changes when we upgrade. And finally, we will be again making all the needed judgment calls for every table, and again hitting the synchronize button and generate. Okay, it keeps crashing because I'm not connected to VPN, and basically, come on. It doesn't like me at all, and effectively again give you basically a long SQL things which you need to actually again check, and yeah, it can get very, 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 very long. Some of this is unnecessary. I haven't filtered it now for demo purposes, but I'm just telling you how it is. So these are the 2 tools that will need special care and a lot of judgment calls to be able to do that correctly. All right, moving forward, risks associated with these database changes, whether they are schema changes or data changes. If you shorten a column length to be in sync with what CloudStack expects, is there any data going to be truncated in this column? So you cannot just bluntly do that. Or if you're lowering the data, the value of maybe number of supported disks for certain hypervisor from 252 in Zen to, I believe, 12 as we have in our database, does any VM has more than 12 disks attached? Will it cause issues if you lower this value? Also, using wrong keys for comparison, which I just show you for the hypervisor capabilities, you cannot use ID, you need to think and then come to a conclusion that the proper comparison key is the combination of hypervisor type and hypervisor version. Also, you need to exclude some fields so you don't have false differences and so on. Also, some things like created, removed, updated are also not relevant. Yeah. Any questions so far? Or everything is clear? All right. So let's just cover a high-level upgrade steps. the first thing you want to ensure is that you have a successful upgrade of a copy of production database, because you will doing a lot of this in a test environment, your own test environment. The idea is to have your database imported to a management server that you built, and it has to be network isolated from any production hypervisor hosted storage, because you don't want your upgraded database and management server to start and then automatically connect to your hypervisor hosted storage. It could or should or will actually by all means cause some mess. This is best done if you use actually a virtual machine, whatever, even a VirtualBox will do. So you can do quick snapshots, and when the database upgrade fails, you can roll back, for example, and so on. And then this is the sandbox copy of the production database. Before you actually succeed in upgrading the database, you will spend a lot of time troubleshooting failed database attempts, which I'm going to cover on the next slide. And once you finally upgrade your database, you want to clean it up with the tools that I've mentioned. Tests, obviously, in a test environment is something you would want to pay special attention to. In general, how this would be done? So the sandboxed upgrade of the copy of production database, you would build your management server, Linux, install CloudStack, target CloudStack version, but don't start it. You would install and configure a target MySQL version on the same host, but don't start it. You would create MySQL user for the cloud and its password, but you don't know that unless the customer has told you. You will later decrypt certain values from the db.properties to learn these, so you'll do this step later on. You do need the key file and the db.properties file from the production environment of your customer or the environment that you are upgrading. You will use the key file to decrypt the database cloud encryption file, which is later needed in the CloudStack setup databases command. You will also use the key file to decrypt the value of the password. This is MySQL user password for the cloud user. And then once you have all this data, you would run the CloudStack setup databases command properly, creating a new db.properties file, which is effectively the whole configuration of the management server and how it should connect to the database, its own database. In the test environments, you also need to simulate a system and templates being registered properly by injecting certain database records. I'm going to talk on this a bit later on. And finally, once you develop a set of scripts to do a pre-upgrade cleanup to ensure a successful upgrade, you will apply those scripts, and only then you would start the management server, tail the logs, and observe how the database gets upgraded, hopefully successfully. Just a couple of things without any details how this is done. Decrypting the values, DB Cloud Encryption Secret or the cloud user is done using this fancy command. Basically, you will be inputting whatever encrypted value, is it DB Cloud Encrypt Secret or DB Cloud Password. You'll use the management key value as the password. You will get the value, and then eventually you will use the CloudStack setup databases with those values, specifying the database host being the same VM where you are working, the cluster node or the management server, again, the same IP, and then you will be specifying the management server and the database encryption key, which you learned by decrypting it over here. Simulating system VM templates, I'm not going to show you on the slide because it's a huge pile of code. You'll see this later when I show you the sample customer demo. Right, so that's the upgrade of the copy of the production database. Now, before you can be successful with that, you need to actually develop a set of pre-upgrade database cleanup scripts. Why this and what does it mean? You will most certainly, well, more frequently than not, have some, let's use the word offending records, extra records in the guest-OS table that will conflict with the SQL files that CloudStack upgrade executes. Because we use specific IDs, and if the row with the same ID is already in the table, it will not be possible to inject the row and the upgrade will fail. Also, you need to learn which CloudStack version is the specific cloud platform based on. So you will need to lower or delete certain rows or lower the version in the version table, just to give an idea. And also, you will need to sometimes do a lot of other SQL changes on the database. Just to show you the fun with CloudPlatform 4.7, it's based on 4.6, CloudStack 4.6, but they have actually backported awful lot of key indexes improvements from CloudStack 4.8, 4.9, and even some from the 4.10. So when you lower the database version to 4.6 and you upgrade CloudStack, it will try to inject all these improvements again, and it will fail. So you need to undo all these improvements in the CloudPlatform database, and only then CloudStack will be able to be upgraded successfully. So yeah, a lot of fun with the DB schema tools and data tools as well. Specific guest OS tables, some records will need to be removed. Also, what's very specific with the guest OS tables, the records in general have started drifting heavily in the last few CloudPlatform releases versus CloudStack. So that's something we are handling in a special way by completely deleting all the records after the upgrade, injecting all the clean records or records from a clean CloudStack installation, and then the true hell begins because all the IDs have been changed. You need to remap all the references from other tables, VM template, VM instance, and so on, which I'll show you a specific slide about that. Version table, again, as I said, you need to work out on which CloudStack version this is based on and then lower it properly. Also, any extra keys and indexes improvements need to be backported, which were backported need to be now undone, so to say, so that the upgrade can work. Once you have all the scripts, once you run your upgrade in the sandbox environment, you would want to bring your database state, schema, and data as close as possible to a clean installation of the clean CloudStack. So just to go show you a couple of examples. Private gateway, if you have a VPC with private gateway, in CloudPlatform they use the word guest, the value guest, in the records in the network and network offering table. No, sorry, the private gateway, they use the word private gateway as a kind of network in the network and network offering table. CloudStack code doesn't know what does this mean because it's now CloudStack code, it's not CloudPlatform code. So you will not be able to deploy new private gateways, you will not be able to restart VPCs which have private gateways, and the things will fail. Something I personally learned on a customer project during testing, thankfully, but after we already delivered the document. So you need to go and change data inside those tables. Also, you need to delete some duplicate SSH key pairs in order to create unique index, which is what CloudStack does on its own. Yeah. And yeah, this is what should go where. This is spaghetti stuff. You need to admire my Microsoft Paint skills, which is the simplest way to show customer how it works. So just to show you this, in CloudPlatform 4.11.7, these are the records from the guest OS table. Just when we upgrade successfully, we will replace the content of this table with the content of the clean target CloudStack 4.13.1 in this case table. And now what's the problem? If you observe just one, Windows 10, 64-bit, it had ID 272, if I read correctly, without my glasses. But now, all of a sudden, it has ID 258. So you will need to develop a set of scripts for all these spaghetti stuff to basically change the references in other tables which reference them by IDs. So if you have a VM which says my guest OS ID was 272, now it should not be 272, now it should be 258. So you need to do a set of scripts to basically do the proper remapping is the word I've used. But yeah, and this is a lot of fun, I can tell you. Well, time for a sample customer demo, or some customer project actually for that matter. Right, this one was developed for the Acme Corporation, specifically to Mr. Bugs Bunny, as you can probably see on the slide. This is what we developed to our delivered to our customers. This is one of the deliverables. beside the set of SQL scripts which we generate with mentioned dbForge, the schema and data comparison tools. So what we would do, we would have revision tables, table of content, and blah, blah, blah. Some references, some high level, or let me actually use my mouse probably. Sorry for that. All right, hopefully now it's a bit more readable. So we do a bit of introduction. We have something called risk and issue register, where we notice any risks and see what's the workarounds around there. And we also try to touch them in a specific chapters, let's say, if it's possible. We also notice if the risk is owned by ShapeBlue or by the customer. Beside those risks, we also have certain assumptions and limitations section over here. Again, when we agree something with customer, you know, division of duties, so to say, or anything else, we really want to make sure that everything is on the paper, it's very transparent and visible to everybody. So beside this, we now describe, for example, existing customer environment with as much details as we have, number of pods, clusters, hypervisors, you know, what's their current management platform, is it virtual physical servers, the size of these, and so on, disk space, database servers, everything. So we basically try to document customer environment during the workshops that we have with them, including, you know, CloudPlatform versions which are installed and any patches and so on. Then also we define, you know, the hypervisors. In this specific example, the customer had also Zen, and they also had vCenter. We define storage. Well, not define, sorry, we document storage. That's all, you know, how the traffic is split across various physical networks, bonds, and this and that. So as many details as possible. And then we try to say, okay, which are the upgrade versions we are moving from whatever, for example, CloudPlatform 4.7 to CloudStack 4.14. We are moving from certain operating system for the management and database servers to different ones, which we agree in advance with our customer, based on their preferences, our advices, expertise they have, and so on, including MySQL version as well. Hypervisors, just there for the sake of being there, but mostly customer never touches those. So later on, yeah, we describe the new environment, the new management server environment, MySQL servers, CloudStack management servers, and so on. And then we have detailed steps for building the new set of management servers, which commands to run, what to do, what to download, what repositories to use, what to install, and so on. And this can be done before the actual upgrade. So we have a nice line which says no further steps before the actual upgrade. Then also we give very detailed instructions on how to build MySQL servers. This is something we do and give to our customers. Of course, if our customers are more proficient in MySQL builds and their specific master, slave, or Galera, or whatever setup, it's up to them to just take this as a baseline or simply drop this completely and do it on their own. We give certain details over here, including detailed configuration of the MySQL with all the optimizations and such. We also give instructions on how to configure master slave, or is it now main and replica setup, replication. We also give them instructions how to create MySQL users, but this has to be first learned by decrypting the db.properties values. And all of this can be done literally months or weeks or days before the actual upgrade. And then when it comes to the actual upgrade, you want to ensure that your system VM templates for the new CloudStack version are there. This customer had both Zen and KVM, so we ensure and giving detailed instructions on how to register those, and then simply going through the rest of the procedure where they will be stopping their old management servers and MySQL servers. They will be starting new ones later on. They will do database dumps. Basically, we want to back up all the databases so that we can import them to a new set of MySQL servers. stop the source or the old MySQL service and so on, and import database to a new one. A lot of details over here, but I won't bother you now with how to configure master-slave replication. This is basically what I was referring to previously, with all the details that are more than enough for a production-ready setup. But again, customer is free to use their own procedures if they want. Then a couple of, I won't say hacks, but optimizations that needs to be done. How to set the host value if you have multiple management servers, later how to change and which value, so it's load balance across 2 management servers and so on. And now goes the funny part, prepare the database for the upgrade. From here on, we actually advise customer to jump to a section 8.1, which I'm actually going to do as we speak. I was on page 35. Here, before the customer can upgrade their database, they have already imported it, right? But before they can upgrade, they need to do certain changes. So for example, they need to delete from the version table all the rows above version 6.0. And also this specific customer had probably version 4.6.1 or something like that. So we just say it has to be explicitly for 6.0. And that's something you learn by, I would say, trials and errors. Then also we need to remove some duplicate rows or offending rows in the guest OS table so that the MySQL upgrade can inject the rows with the same IDs. And for this specific customer, we had to also backport to undo backporting a huge number of index keys, fixes, and so on. So just for fun, well, at least somebody's fun, I'm going to show you pre-upgrade steps. So we need to create certain indices. We need to drop certain indexes. We need to alter many tables, many indexes. And this is all undo of the backport of all these optimizations from 4.8, 4.9, 4.10, so that the CloudStack can actually do the same. And now I'm going to actually go back to my page 35, if I remember correctly. Yeah. After you prepare your database, you would ensure that your original CloudStack management hosts on the old management platform are disabled, and stop them, and then also set the specific things which are required for optimization purposes so that the host can connect faster. A lot of technical things which I don't want to bore you with, but eventually we will be set up the CloudStack database, the dbForge properties with certain commands. And again, here we give reference on how to learn the database encryption keys, the Cloud DB password here, the Cloud database encryption keys by decrypting those values from the old db properties. Finally, we're starting the Apache and tailing off the logs and ensuring that we get a proper message that the database was upgraded to whatever target version. So yeah, that's kind of it. Later on, we handle certain special cases. Here we need to perform now the post-upgrade database cleanup, which means that we should go to a certain chapter in the guide, and I'll show you this a bit later on. But also here we are handling, this is just an example, the passwords for all the users in the upgraded database can no more be decrypted by the CloudStack, because we use different number of passes for the passwords, and CloudPlatform used different number of passes than CloudStack. So none of the users are able to actually log in. So we here give a procedure on how to actually touch on this subject. And also we define certain rollback, let's say, steps. So yeah, I'm not going to bore you through all the other details. We also configure the second management server, the usage server, we start those, and so on. Now, moving to the post-database upgrade cleanup, I'm just going to show you. To find that one. Right, so we here provide in this appendix, we give a detailed steps for the customer how to do their own sandboxed test upgrade of the copy of the production database, which steps to run. And then this is what I was referring to after you configure DB properties and everything else, because you don't, you just have a database on premise in a isolated VM. You need to simulate that the specific system VM templates are present by injecting your system VM templates for Zen, and then also by injecting your system VM template for the VMware, so that the database upgrade will actually work. Otherwise, it will fail if it doesn't find the proper rows, and so on and so forth. Now, the thing, this is section 8.2. I'm going to show you just one or two SQL files, not to damage your brain too much. We need to restore the content of the guest OS table. This is something I've mentioned. I show you this picture with spaghetti stuff. I'm going to show you actually the sequels for that as well. We need to remap all the references in the VM instance, VM template, guest OS hypervisor tables, because the IDs have now changed in the guest OS table because we've replaced the content of that one. This is the same image again, but for this specific project. We need to update the configuration table, hypervisor table. These are all set of scripts that we've developed by simply going through the project. So just to keep it, let's say, short and not too brain destructive, I'm going to show you, for example, this is the remapping of the guest OS references. We need to do this with some so-called temporary tables. But here, based on this spaghetti image, we notice the IDs which were changed and to which IDs we need to remap those. So we here have the IDs of the original table, and now we are updating them. We are saying update VM instance at get OS equal 258, where it was whatever 272. This is example actually of the Windows 10, I believe. If you remember, the original ID was 272, and once we replace the content of the guest OS table, the ID is 258. So we need to do this in all the different tables, and it can be it can be a pain in that sense. So yeah, that's pretty much it. This is just part of the deliverables. Just give me a second. So basically, this is a set of scripts that we have for this specific customer to add guest OS records, to change the details because those are Zen related, to remap the guest OS differences, which is what I've just shown, to clean up the configuration table, and so on and so forth. We also sometimes have to fix cloud usage schema as well. It depends. And also we have DB properties and the key files from this customer. So that's kind of it. Not your usual, let's say, upgrade project, but it can be fun, at least for some. So I think that's pretty much all. Any questions are welcome, if anybody has any. Right.
I think we're ready. Okay, so I start first with the questions which we have online, and then we have a few questions in the room. So obviously, some people didn't realize that this cloud platform still exists. So do you think it will continue with its existence?
I think it will for some time, but we've seen more and more customers actually moving away from cloud platform to CloudStack. without naming the reasons, I'm pretty sure they have good solid reasons, because CloudStack development is actually very actively continues very actively. We have literally daily new features and bug fixes and everything else, and it's a huge community, very active community, awful lot of nice work being done. I can't say for sure, but based on what I know, I don't think that's the case with CloudPlatform, because it's a kind of a closed source with a certainly smaller set of people who are surely great ones, but it's much smaller team, and there hasn't been any improvement lately. No jump in versions, for example, in CloudPlatform, sorry.
Okay, and what kind of scale environments have you migrated?
Sorry, what?
What scale environments have you migrated? Like, what's the scale of the environments?
We've migrated some small environments as well, but there were some pretty decent sized environments with a couple of hundred hypervisors actually, and people were more than happy to be able to evolve and use newer features of which CloudStack now provides that are not available in CloudPlatform.
Can you share a little bit more about the migrations? What is the typical maintenance window required, and what does the downtime look like?
Right. Well, most of the new, to prepare the new set of the management and database servers and everything else, you can do that basically. Before weeks and days before the actual upgrade. I would say it depends on how you do this. We've recently migrated one huge institute, and the actual upgrade itself was maybe a couple of hours of downtime of the management plane. So the user VMs are not affected, the traffic, the workloads, nothing is affected. It's just the management plane. So you put a nice under construction page or maintenance page or whatever. There is a different thing where you want to, because you have to restart and upgrade customers' virtual routers. That's something you can schedule during night, and that can take probably 5 to 6 to 8 hours. In this last project, it was a huge institute with, I think, a couple of thousands of virtual routers, which took time, but you can always agree with your customers at what time you want to do that. So nothing major, no major workload downtime. That's the key point, I guess.
Okay, we continue with questions here.
Hi, Andrija. Thank you. Great talk. My question's similar to that last one. How long it takes, but how long does the planning of a project like this take? Not the actual execution over the weekend or whatever. How long does it actually take you?
The preparation, yeah.
Yeah, and also is that time scale dependent? Bigger environments, they take longer. Smaller environments, that sort of thing.
All right, thanks. I would say here we have usually what we do. Let's say a couple of workshops worth of 10-15 hours, depends on each customer, to learn all the details so that we can document it, and then a couple of tens of hours are usually to actually do the project, well, in-house pretty much on the ShapeBlue side, to prepare everything and then to deliver a working set of deliverables, which is the project document and all the SQL scripts. So I would say less than 100 hours, sometimes even 50, 60 hours can be enough. Unless this is something new, a challenge, maybe different CloudPlatform version with a new specifics where you need to spend more time with database analysis and comparison. So.
Okay, next question.
Great presentation, Andrija. And which hypervisors is easier to migrate and the easiest?
This is not really that much of a variable, I would say. We've seen some issues with Zen because of certain codes, part of the codes used where we had to hack the database again. We had host disconnections and stuff like that after the upgrade, which was impossible to learn during the process, but it was a minimum downtime, just again the management plane. I would say it's pretty much irrelevant. There's a couple of specials for VMware and for Zen that you want to document properly, so not much difference at all.
Next question here, please.
Hi, congratulations on both the slides and the project. It looks like rocket science where I'm standing. Two quick questions. Actually, even with the dbForge app, it looks like the database was the greatest problem to solve. But beyond that, do you remember any tricky problems or gotchas that gave you trouble? And the second question is, not being familiar with CloudPlatform, has the customer lost any feature that they were keen on in the process?
All right. No special issues, I would say. For me, the largest challenge was actually going through the database and spending time there. And because you need to make judgment calls all the time, especially whether you want to change something, is it worth the risk? What's the possible benefits, if any? And if there are no benefits whatsoever, but the risk is there, then better not touch it. If it's not broken, don't fix it. Sorry, what was the other one? Any features, yeah. There were a couple of new features, but thankfully they were not used by the customers. There were a couple of interesting features, actually, which we even actually added on our roadmap as a community. But no, so far I haven't seen any single feature that was lost, because those were like a niche cases or niche features that were implemented for specific, probably, customers. What I do know, for example, might be a bad marketing for us, but officially CloudPlatform supported Hyper-V, or at least there were records and stuff that indicated that it was actively supported. Whether it really was, I don't know. And that's something that we are yet to improve in CloudStack. Yeah.
Thank you, Andrija. Do we have any other questions? No? Okay. So yeah, applauses for Andrija.
Thanks.